Can you hear me now?
Yes, I
I don't know if I'm gonna like that, that back feed. Okay. Hopefully, if you are online, you can hear me now, and then we're not getting a lot of feedback from our end. So if you can hear me online, can you just raise your hand or say something in the chat? Okay, awesome. Sorry about that. Just to recap, the average of the exam was an 80. If you'd like to get your exam back, I have them. I'll give them back to you today if you're in person. If you are not here in person today, I will give them back whenever you're back in person, either before or after the next class. They'll be in my office. But yeah, and the key is online. Just go under modules. The second module has the key. So my advice is check your exam against the key. Make sure I didn't make a math error. And then, of course, if there is a mistake or you're concerned about something, come and talk to me during my office hours, but they are available to you. Okay, let's get started. In previous classes, we talked about naming compounds. We talked about naming alkanes and non-binary covalent molecules. And then today and Wednesday, we are going to discuss ionic nomenclature. So if you have this document, I downloaded this and I printed them out a few weeks ago, probably in our second or third class. It's the nomenclature summary. You can find it under resources or under Unit 2. That's where I think I also put it. So you would definitely want this while you are practicing because it's good help to kind of determine between all the different types of namings. So we're going to be doing ionic nomenclature today. Our goal is to write names and formulas for ionic compounds composed of two elements, a metal and a nonmetal. So that's what we mean by ionic. If it was covalent, it would be a nonmetal plus a nonmetal. So it's going to be very important for us to distinguish between the two because now I can ask you an alkane, a covalent bond, an ionic bond. I can ask you a bunch of things, and we need to distinguish between the three types. But this document is going to be really helpful as you are learning. Let's do a review. Ionic versus covalent bonding. I just want to remind you that covalent bonding, when you were naming, we didn't adjust anything. So let's say it was C6H6. Just because you can make it a little bit more simplified, you had to leave everything in there because for covalent, it's required for us to be able to understand the structure. For ionic bonding, it's a little bit different how it's structured because of the metal and non-metal bonds. There's a great question in the review exams where it asks you, the details between the two. So I didn't ask it on this exam because we didn't go into too much depth, but I want to go through that now because I could ask you in a future one. An ionic bond, what holds those two bonds together is not going to be sharing electrons. It's going to be the charges. So remember, opposites attract. So like a negative charge attracts a positive charge. That's what's holding that bond together, but it's not because they're sharing anything. For covalent bonds, the reason why they are bonding is because they are sharing an electron or two electrons. So that's why those bonds are being held together. The charges are they're not strong enough to hold them together. So that's why it's covalent bonding versus ionic. But because ionic bonding is sharing of charges, you can play around with that one to make it more simplified when you do the overall structure. All right, so Review. Ionic, metal plus non-metal. So remember, use the periodic table of elements. Majority of elements are metals, where very few are metalloids and non-metals. So you need to have one of each for this type of bonding. They are solids. When they hit water, they do turn into liquids, but we're only going to be focusing on the solids for this section. They do have extended 3D structures. Here's an example of that. We have NaCl. Previously, with covalent bonding, I would have to incorporate all of the sodiums or all of the chlorines and have a big name based on that. But in this one, it's all about the ratios and creating a formula unit, which we'll do on the next slide. But like, let's say this is Na30, Cl30. It's a 1-to-1 ratio. For every sodium, you have an equal chlorine. We simplify ionic bonds into the formula unit by, finding dividing it out by the common denominator, the smallest common denominator. I forget my basic math, but essentially Na30 and Cl30 is the same thing as NaCl, and you're assuming it's ones. It's the same thing. So that's why we will simplify that one. Oh, covalent bonding, it can definitely be solids, liquids, and gases. They are molecules, not really pure elements. I guess the diatoms would be, like the Brinkelhoffs would be covalently bonded too, but we tend to focus on the other ones. So H2O, CH4, and that's glucose. So metal, all nonmetals. Okay. So writing formulas from structures. So previously, like I mentioned, you can't simplify this. What is this structure? This is what? Yeah, it's hexane. So it's C6H6. I cannot simplify this to be CH because that's a completely different compound. And also carbons tend to have 4 bonds and it has to be proven. So we don't simplify these. Whatever is there, we have to write it. I think this is benzene, by the way. It would be hexane if it was a line, but because it creates that circle, it's a different type of naming, but you won't hit that until organic. How do I write a formula for this? It's much more difficult because I can't really count it because they have some behind it. It's all 3D structured. But I do know that for this one, this is NaCl, just because they had it on the last slide. It's the same thing, purple and green. It's a 1-to-1 ratio, and it's going to be very difficult for us to write the exact formula. But if I have the simplest form, it's easy to figure that out. So it's empirical formula or formula units, it's the smallest whole number ratio between elements. So like I had on the previous slide, if I was to go and count all these, which no one has time to do that, it's Na 172 and chlorine 172. And let's be real, if I had a giant thing of salt right now, it would be much larger. It'd be like Na 6x times 10 to the 50th. I don't know. It's a lot of atoms. So we simplify it because there is a 1-to-1 ratio. That is just going to be NaCl to save time. But it's the same thing. And this is always used for ionic compounds that are solid. So formula units is the simplest version or the collection of atoms indicated by the formula for a compound. So we always do the simplest form. If I was to put 1-to-1 ratio up there, would y'all understand what I mean by that? It means that for every 1 sodium, I have an equal same amount of chlorine. So it's a 1-to-1 ratio. If I was to start playing around, do like a 1-to-2 ratio, that would also change things. But in this case, it is 1-to-1. Okay. Let's practice reducing the empirical formula. I'll do the first one, and then I'll let y'all go ahead and do it. Because all of these are a metal plus a non-metal, I'll tell you they are. If I go and look at the periodic table, I can confirm it. They're going to reduce to the simplest form. So if there is a common denominator between them, I'll just divide it out by that. If I can't reduce it anymore, it's as is. So this first one, I can divide both of them by 2, and that would get me FeO. And that would be the correct units. It would be, the simplest form FeO. I'll let y'all do the next 3, and then we'll come back and check. Okay, what'd y'all get for the second one?
Three.
Yes, I can divide both of these by 3. So that would be CrO3. What about the next one? Yes, I can divide them both by 2, and that gives me Ti and O2. What about the last one?
Let's just say this.
Yes, I can always make it go up, but I can't make this one any smaller. So this one will just be FeO3. So sometimes I can give you a problem that has these types of, numbers in there, and I'm expecting you to be able to like spit out the correct empirical formula. So just divide by maybe the highest common denominator would be for these, because, we can always divide by 1, but if there's a higher one, divide by the higher one. Okay. All right, so on the left-hand side, we have what we've already gotten comfortable with, the binary covalent molecular compounds. And just to review, we do not include the prefix mono on the first element, but we do write the element out as is. If it has a different number, we include the prefix. And then the second element, you have the prefix no matter what, and then it's the element, but the last 3 are replaced with an IDE. I do want to point out there is something in common between the covalent and the ionic. They're always going to end in "ide." So that's the one thing you want to get comfortable is, having them both end in "ide." But you can see everything else is completely different. That's why we want to be very comfortable knowing the difference between them and identifying which is which. So when it comes to metals, we tend to not add prefixes in them. We just say metal. We'll hit charges later on, but we just say metal. And then we also don't put prefixes on the other elements. So in this case, there's no more prefixes if it's an ionic bond. So this one, we have lead fluoride. This kind of, we'll go into this in part 2, but that kind of tells you the charge. Aluminum oxide. So yes, if I look at this, I cannot really create a molecule because it's just metal plus something "ide." It doesn't tell you the prefixes, but I'll teach you how you can kind of take that and create what its formula is. But this is why it's going to be a little bit challenging in the beginning when we go from something that was so straightforward to a little bit less straightforward. So yeah, for ionic compounds, we are losing the prefixes, but you still need to remember the prefixes for alkanes and the binary covalent molecules. Okay. How do we know what subscripts to write in the formula without the prefixes in the name? Yes, it's confusing, but I'm going to help you. Okay. First, metals will always have a positive charge, always. They are called cations. So it means positively charged ion. The charges will vary depending on each metal, but they will always have a positive charge. Non-metals, either by themselves or with something else, are going to always have a negative charge, and they are what we called anions. Anions are negatively charged ions, and that's going to be always there, and you want to be definitely comfortable knowing which one's the non-metal and which one's the metal. So each compound needs enough metal and non-metal ions so that the overall charge is 0. So the way that I kind of do this in my head is here, I have Fe2O3. I just counted them up. But I have 3 or +3 and +3. What is my charge when I add those up?
6.
+6. Because it's going to be a positive. You want it, even though I know 6 is positive, right now we want to include it. If I have -2 plus -2 plus -2, what do I get? -6. So if I add up +6 and -6, what do I get? 0. And that's how I can confirm that this compound is correct. If all of the charges add up to 0, this is a correct compound. I might not be able to know the charges on top, but they were nice enough to give us those charges. And that's how I can tell it's Fe2O3. All right. Now here is where I would like everyone to get out their personal periodic table of elements. I didn't bring any extra copies, But if you have yours with you, please get it out or be able to take notes or maybe make a one on your notes real quick. But we're gonna make some notes here. It's okay. If you want to just like make a rough version or, just make a reminder to come back to this slide. But here's what I want y'all to get comfortable. So I'll do it online right here and then we'll walk over the periodic table of elements and I will, show you. But column 1. So you see where it's all those purple ones on my slide. So hydrogen also does count, but we're really focusing on the metals here. That's why hydrogen's not included. But typically it's going to have a +1 charge. So I'm okay with you above column 1, putting a +1. So if I was to ask you about any metal from column 1, you'll know +1. Column 2, +2. So if I was to ask you the charge of any of those column 2 metals, magnesium, calcium, strontium, they're always going to have a +2 charge. They do not adjust when we get to electron configuration. I'll explain why, but they are selfishly only want to be +2. The halogens, I know the halogens are not highlighted in purple here, but I've talked to you and I've told you how selfish they are. They don't share their electrons. They don't share anything. They are 0 charge. They're not going to have any charge. We are never going to actually include the halogens in here, but I also want you being comfortable knowing halogens will be a 0 charge always. They are neutral. They are full octets. They're happy, 0 charge. Did I say halogens? I meant noble gases. I'm so sorry. I'm thinking noble gases and I'm saying halogens. The last column, column 8. I apologize. Column 8, helium, neon, argon, xenon. They are gases. They are selfish. They want to be by themselves. So that last column is a 0 charge. Thanks for catching that. Halogens is the second to last column. Those will have a -1 charge. Always -1. So, and it ends at iodine. So once you get past iodine, you're now in a metalloid. We're not talking about them. So I'm just talking about the non-metals that are highlighted in purple here. So fluorine all the way to iodine will have a -1 charge always. The next column over, you can put a -2. And then the next column over above nitrogen, you could put a -3. Carbon will typically, that column will typically be a 0 neutral charge. Carbon doesn't really want to be charged. But if you see aluminum, which I have, let me, get a different color. Aluminum here. That one's a +3, always. So let me put it up here. We have +1, +2, 0, -1, -2, -3, 0, +3. I know I'm being messy. And then this one will have a +2, and I'm only talking about these. The zinc and the cadmium will always be +2. And then silver will always be a +1. These are not really expecting you to memorize. I'm just pointing out the ones that are always. It's going to be very helpful if you have your own periodic table of elements to kind of label this as you do this to kind of help you. Everything else in between, the charges will vary, but at least knowing the ones that are always will help make our lives a lot better. Okay, so let's review. Let me see if I can. What charge?
-1.
Okay. What charge?
It's 2,
What charge?
3. Oh, wait. Yeah, 2. 2 +2.
What charge?
4, positive,
Aluminum, a charge.
positive 3,
This column?
plus 1,
Okay. Nitrogen.
negative 3,
Sulfur.
negative 2,
Selenium.
negative 2.
So kind of doing that will help you be more comfortable. And then we're gonna get a lot of practice in, but that's gonna be very helpful is knowing the definites because everything else will be, I don't quite know, and I'll show you how we can know. Okay. So we're gonna be getting into naming. Cations, the metals, you're just gonna name the metal as is. I'll remind you, the periodic table of elements that I provided doesn't have those metal names. This will always be in here, especially for exams and things like that. That's why I'm always gonna be like, just get up and go look if you need to. But if you don't know the elements, at least that's gonna be there in the exams to help. You'll get more comfortable as it goes on, and then I'll help when they get a little confusing in the slides. But you're just gonna name the metal as is. Like I know some of the metals are weird. Like if I was to say like RU, I can't even like sometimes look up and to be like, what is RU? So that's when you wanna double check or maybe have a periodic table of elements in front of you through an app or your computer. I like the pdtable.com is a great one. So as you're studying, that's a good one to look at to get more comfortable with element names. If it was by itself, so if I was just to have Al by itself, you would just say aluminum ion. If you mix it with another metal, you'll just say aluminum something. But since this is by itself, I will say aluminum ion, or it's a cation, but it's aluminum ion because it's positively charged. Anions will always end in "ide." So oxygen will turn into oxide. Sulfur will turn into sulfide. Phosphorus, phosphide, if you have to go there. It's the same concept as the binary covalent. You'll end everything in "ide." We haven't hit polyatomic ions yet. When we get there, it will change a little bit. But for this case, it's going to be an element by itself. It ends in "ide." And they added ion to the end of this because if this is by itself, it's just going to be sulfide ion. Okay. Let's practice first. What is the charge of zinc? +2. Now you can do 2+ or you can do +2. They're synonymous as long as you have that 2 charge. You wouldn't just do 2. You have to have the plus charge. So zinc is 2+. Name and formula. So the formula is going to be zinc 2+. And then what is the name? So is it attached to another thing? So it's not going to be just zinc by itself. I have to put zinc what? Ion. Next, let's move on to fluoride, right? What is the charge of fluorine? It's a halogen. It will always have a -1 charge. Now you can just do a negative sign for -1, or if you would like to do a -1, you'll see me always just do a negative sign because we're always assuming if there's no number, it's 1. But you need to do what you feel most comfortable with. I wouldn't tell you take off points if you had -1 here, but it's a negative charge. So this would not be fluorine ion because it would be the second one always. It would be fluoride ion. Okay. What is the charge of nitrogen? -3. And then would this be nitrogen ion or something else? Nitride, yes. Okay, last, we have calcium. What column is calcium on?
+2.
Column 2, so it is a +2 charge. And it's a metal, so you'll leave the metal name as is, and then ion, if it's by itself with the charge. Not so bad. So in these cases, we're gonna have to definitely use our periodic table elements and then know where on the periodic table they are. That's probably the hardest part. So let's go into writing formulas. This is when we start attaching two things together. Write the formula for the cation and the anion. So we already talked about Na and Cl. Sodium, what charge is going to be Na? What column is it in? First one, so it'll be a +1. Chlorine, -1. Okay, so this would be an example of an ionic bond. So I have sodium and chlorine, and I made sure I noted what their charges was. So write the formula for the cation and the anion. If the charges cancel out, stop. So if I was to add +1 and -1, what is the overall charge? This would be an example of if the charges are the same and they cancel out, stop. This is just going to be NaCl. That's it. But sometimes the charges do not cancel. So I'll give you an example of when the charges do not cancel. Actually, we haven't hit iron yet. That'd be cruel. Let's do zinc and chlorine. Wait, let me check. Okay, so I want to make sure it's a different one. Okay, so what is the charge of zinc? +2. And what's the charge of chlorine again? Okay, so these do not cancel because, sorry. Yeah, that's where I'm getting, I'm like messing my head up. If I was to add +2 and -1, I would not get 0. So this one is not correct. I cannot leave it as zinc chloride. So this is what Dr. Patterson is saying. Take the number from the charge on the cation and cross it down as a subscript on the anion. Take the number from the charge on the anion and crisscross it and add it as a subscript of the cation. So now I have zinc So zinc chloride. So zinc, and then there's two Cls. So +2, and then I have -1 and -1. If I add them up, what do I get? So +2 and then -1, -1. It would be 0. That's how you can correct yourself. Okay, is this the correct one? And that's if all of the charges add them up. If they ends up being 0, it's correct. So this would be zinc chloride. So 2 Cls. Once again, the charge goes into the opposite or the crisscross subscript. If you're comfortable doing this in your head, this is a really good, helpful way if you're not comfortable doing this in your head. If you're really good at doing math in your head and understanding these charges, you don't need to do the crisscross method. It's just an example of, okay, I just needed to add up to 0. But as you're learning, this is a great way to start before it gets into your head. So take the charges, crisscross them, and move them into the subscripts. And then make sure it is an empirical formula, and if not, reduce it to the lowest level. I can't reduce this any further. This is correct. Clean up. Charges and work. So see how this is all a mess? The end answer would be this. So clean it up, make sure the work's not shown in the final answer. Okay, let's practice. We already did sodium chloride. We already did that one, so I'll leave it as is. Let's do barium bromide. So barium, Ba is going to be the symbol for that. Bromide, Br. What is the charge of barium? It's at the bottom of column 2. +2. And then bromide? -1, yes. So I'm going to take the +2 and I'm going to move it over here. And I'm going to take the 1 and move it over here. And that gives me BaBr2. So let me check my math. So that's when I have a +2 and I have -1 and -1. If I add everything up, I end up with a 0. So this is correct. BA, BR2. And to clean everything up, could circle it, things like that. I'll let y'all do the next two.
Professor. Professor. No, she can hear me.
What's the charge of aluminum? What's the charge of fluorine? What about oxygen? Okay, now y'all can do the crisscross method. What did you get for number 3?
AL. 3.
So the 3 will come here, the 1 will come here. Yes. What about the next one? So the 3 will come here, the 2 will come here. I know this is a negative one, but we're just kind of putting absolute value around it because you can't have something to the negative subscript. But that's just the number we're pulling. So Al2O3. How do you feel about that? It just takes a little practice if you're kind of uncomfortable with it. The more you do it, the better. And we have tons of practice to do. Okay. All right, so writing names from ionic formulas, this is what we covered in this lecture. Name the cations, the metal. It's going to be just the metal. Fixed charge metal, just element name. So if I have barium, just put barium something. But we're going to start attaching it to the nonmetal. So metal and nonmetal. The nonmetal is just going to be the element name with "ide." Now, I know I have grayed out portions, but that's going to be in parts 2 and 3. Today, we're, in part 1, it's just going to be these. So yeah, so metal. So previous ones, you can see they put the metal all by itself. That's the name, it's by itself. And then element with "ide." So chlorine is chloride. Bromine is bromide. Oxygen is oxide. So you'll just end it with "ide." Okay. Let's practice. Write the formulas and names for the compounds formed by these. Y'all go ahead and do these, and then we'll check the answers and then move on. Okay, so what's the charge of calcium? Okay, chlorine, so. What's the name? Yep. So we have the CaCl2, calcium is the full metal, and then chloride. All right, let's do aluminum sulfur. So what's the charge of aluminum? Sulfur? Did y'all get that? All right, what's the name? Yes. Okay. And last one, charge of sodium. Charge of nitrogen. No. Yes. All right, so we'll flip flop them. And now I have Na3N. Did y'all get that? Okay, so name? Yay, okay. So now I'm gonna ask everyone to, if you're online, download the very first activity. It should be called binary fixed charge covalent nomenclature. So until the break, we're gonna work on this page. So if you are in person, grab that. And we'll work on that for the next 12 minutes.
Yes, ma'am, both the one, the worksheet. Yes, ma'am.
We have a few minutes left, so I guess we could do a few of these. The key online, the key to this is gonna be under modules unit 2 after the worksheet. So you have a blank worksheet, and if you want to check your answers, definitely take a look at the key. I guess I'm gonna skip around. I want to do KP. So it wants us to ask like to put the charges. What's the charge for potassium? +1. What about phosphorus? -3. So the formula, if I was to do the crisscross method, I would have K3P. So what's the name?
Potassium phosphide.
So you have the full metal, regardless of how many of them there are, and then phosphide, regardless of how many they are. Let's do rubidium iodide. RB, where is that on the periodic table?
First column.
First column, so +1 and -1. So that one is pretty simple. If it's, the same number on both of them, it'll be just R, B, and I. So rubidium iodide. If I'm spelling's a little wonky, don't judge me. Ooh, let's do this one. A, G, and S. That's silver, right? All right, what's the charge of silver? Always. +1, and then sulfur?
-2.
-2. So crisscross Ag2S. So silver sulfide. How do you feel about this kind of stuff? Awesome. Yeah. If you want to get the rest of these answers, they are under modules. All right. It just turned 12:49, so let's take a mental break and we'll come back at 12:54. So stand up, maybe go stand out in the sun for a little bit, and then we'll get back. Mhm.
Sulfur, up there, it says sulfur is good.
It's a chalcogen.
Huh?
It's a chalcogen. It's asking for the family name chalcogen. Mhm. So you have alkali earth metal, chalcogens, halogens, noble gases, transition metals.
And not have on the, oh, it didn't say it on the.
It's not going to. I'm not gonna make your lives easy. But that's why I said example
That's-
halogen.
Yeah.
That was
okay.
one column.
Now I understand.
Yeah.
Okay, thank you.
You're welcome.
You know how to put tickets into like maintenance?
Like iPad
Computers?
or, yeah. Is there something wrong with one of our classrooms?
Well, just in the hallway, one of the diffusers is leaking water. I'm sure it's just condensation, but
Yeah, I can do work order.
and then just some ceiling tiles and stuff.
Yeah, that stuff I'm like, I only do it unless like it's emergency, just because I don't want to annoy the certain people.
Fair enough.
They get really frustrated. Even though you're 100% correct. ITAC, I have to now call them about the microphone. They fixed the camera. They completely replaced the camera, but now I gotta, do another work request for the microphone. So I'll do that today, and then I'll go take a look at the leak, because leaks are definitely a big deal. I'm hoping to get us a new building in the next 10 years. It's crazy to me because this building to me is not old, built in 1985. But why does it feel so old? I don't know. Maybe I'm showing my age because
Like stuff falling apart, like what,
yeah.
a little bit.
No, it's more like if you go see, when you hit the labs, you'll know what I'm talking about. Like, it just doesn't feel as like, I don't know, you go to certain campuses and let's say you go to the biology building compared to this, and the biology building's much newer. But it just feels so new and fresh. And like this building, it's like built in 1985, not even that old, but it doesn't feel as new. I don't know where your normal buildings are. This is the older section.
Gotcha.
Oh my gosh. I'll pass out the other. I think we'll have time to hit it today. Yeah, metals are fun. Yeah. Metals are a lot of fun. So that's if you go into inorganic. So I don't like organic chemistry, but I do like inorganic chemistry because the metals just make things more fun. That's just my bias. If you like organic, don't listen to me. I thought I paused the recording. I guess it's still going. All right, let's get started again. We are going to do part 2. We are going to start to do something new. We're going to start introducing things that it's not quite known the charges, and I will show you how to figure them out. Don't panic. I feel like this material, as you get more and more comfortable, just focus on what you are comfortable with. And then once you get really comfortable, then we can start building. But practice is going to be the main thing. So my advice is when you are done today, before next class, open up 2.1's homework and at least answer those problems. The next set of homework will not be as long, I promise, maybe 4 of them, but I don't want y'all waiting until the last 48 hours before the exam to do the homework, because that's the big thing on studying efficiently versus studying. It definitely helps you study, but you want to study efficiently before the exam. So get them done while we hit the lectures. I guess, if we finish 2.1 on Wednesday, maybe make it a goal to finish 2.1 this week. That'd be a great goal. And then we'll hit 2.2 on Friday. But yeah, so as we go through and you get more and more comfortable, it will get easier. So this section, we're going to start introducing something a little different. So our goal, once again, is to write names and formulas for all ionic compounds composed of 2 elements, a metal and a non-metal. That's just what ionic means. They are sharing a charge, not sharing electrons. They are bonded through the strength of those charges. Let's talk about Roman numerals, okay? So for Rusty, Roman numerals, it looks like a giant I for 1. And then as I start adding more, I'll just keep adding. And then what does 4 look like? IV. And I'll tell you now, when I was doing your practice assignment here and your activities and the homeworks, I keep in my head flipping 4 and 6, just double check. So 5, V, 6 is the exact opposite of 4. So make sure you just double check. And then 7 is VII. That's not 7. Yeah. Yeah, so we're gonna now use Roman numerals to represent charges. So if a metal has a +4 charge, we will start using the Roman numeral. So now we can actually start figuring out these charges based on the Roman numerals. But I want to point out, if it's a fixed charge, meaning what we did in the last part 1. So if it's column 1, column 2, if it's, and I'm talking about the metals right now. So if it's column 1, column 2, if it's zinc, cadmium, or silver, you will never put a Roman numeral because it's fixed. We know what the charge is. It will always be one charge. So these Roman numerals are only going to be used for non-fixed charges. And that just takes getting more comfortable with it. And I might have to point it out to you and say, don't use it. But just remember, don't. Fixed charges do not use Roman numerals. Just to review, ionic bonding is metal plus non-metal. We're only focusing on the solids. And you want to make sure that when you give a formula, it's the simplest version of that formula or the formula unit empirical formula. So this is definitely more than one Na and Cl, but the simplest version is NaCl. Okay. This is just a review of the last one. I think typically we would do this class in several times throughout a week. So that's probably why we're reviewing this in case students forgot. So we'll just review it for a moment, but we definitely hit on this. Metals positively charged, non-metals negative charge. Metals are cations, non-metals are anions. So if I was to count everything up, all of the positive charges plus all of the negative charges, they would add up to be 0. And if it's 0, then you have a correct compound. So it has to be the simplest version of it, and it has to be 0 charge-wise. Let's review. What is the charge of this first column? +1. What about the second column? +2. What about this column? Noble gases will always be 0. I know it's not highlighted there, but you'll see that when you hit Gen Chem 1 or engineering. So noble gas is 0. What about this column? -1. This column. -2. This column. -3. Carbon, I gotta look into them. It's pretty much 0. I'm not, I gotta double check and make sure it's not -4, but actually I'll give you that. I'll say it's -4. I'm sorry. We just haven't seen carbon yet. It's so rare. What about aluminum? What about zinc and cadmium? And then silver. So just review, we're gonna say carbon is -4. Just in case, we just don't see it very often. It's so rare. Even I gotta confirm, where we've seen everything else multiple times. So we'll just say carbon is -4. But from my perspective, when you hit organic, it's not always. Everything else, every other metal is gonna be able to have multiple different charges. So like iron can have a +2 or +3 charge. And we do have to be able to decipher which one it is based on maybe the name itself, if they're Roman numerals, or we just have to play around with those charges. And I'll show you how to do that. Okay. So name it. So I'm sorry, we're gonna name it. So remember those Roman numerals represents charge. And then for a metal, you don't play around with the name. You just write iron. Fe is iron, by the way. So the start of both of these will be the same, but in Roman numerals, what am I going to put after the first one? And then the second one? Yeah, that's all it's asking. It's asking just to figure out what is the charge and then write it in Roman numerals. So whatever charge I throw at you, you're going to put it in parentheses. Let's practice. Um, you might be rusty on the element name, no worries. That's why it's important to have, a big periodic elements you can check. This one is manganese. And this is a really, really fun metal because at different charges, it's different colors. We use this a lot in an organic lab. So like, I think at the +7, it's this beautiful purple color. And then at like a +3, it's like a beautiful dark green. But I know it can be like a blue color at one charge. It's manganese is gorgeous. But yeah, manganese is one of those metals that it has a multiple different charges and then different colors. So what am I going to put in parentheses? 7. So that would be VII to let us know, to let us know that manganese has a +7 charge. This is titanium. And then what am I putting in parentheses? And this AG, I think that's, yeah, silver. Is this a fixed metal or a fixed number? Don't be tempted and put a Roman numeral here. I think she threw this in here to try to trick us, but in this case, this is a fixed metal that will always have a +1 charge. So we do not need to put in parentheses a 1. If you see an exam, it might be, that might be an answer option to try to tempt you, but just get comfortable knowing if it's fixed, if it's highlighted in purple here and it's a metal, you will never need to put the parentheses. Okay, that just takes practice. So silver, I will leave this as is. Chromium, that's going to be Cr. What charge? That's a 6, so 6+ or +6. Copper is Cu. What charge? 2+. And once again, you can do +2 or 2+. They are synonymous. Whatever you feel more comfortable with. And I'll be honest, I flip-flop all the time. But I've had like professors that were very, very strict in graduate school, but I don't like those professors. I can't help it. I just flip-flop. I just do it all the time. It's the same thing. I'm biased. But yeah, so this just takes a little bit of practice. Just the hard part is if it's fixed, don't include that Roman numeral. Okay. Just a reminder about the crisscrossing. If you know those element charges, let's say that's a 3+. The crisscross would be, you flip-flop the number. So don't worry if it's a negative, you just flip-flop the number, and now you have Fe2O3, and those charges, when you add them all up, should equal 0. So this is just good practice, but I think as of now, since you've done this so many times, you might not need to do all of it. You can start doing things in your head, but until you are there, practice the crisscross method. This is going to be great because we're going to start throwing other numbers at you now, like 5s and 6s and 7s. It's not going to be so easy, whereas before with those fixed numbers, they were a lot easier. Okay, let's practice writing the formulas. I'll do the first one and I'll let y'all do the rest of them. So copper, what is the charge of copper? So you don't even need to look at the periodic table of elements because they give it to you. So copper 2+. What is the charge of chloride? -1. So I'm going to flip-flop these numbers and I'm going to have Cu, Cl2. And I double check 2+, -1, -1 add up to be 0. So this is correct. Copper chloride. All right, y'all do the next ones. And if you need your periodic table of elements, if you're online, just look up pdtable.com. If you're in person, no worries if you need to get up and go look at it, because I know like I couldn't find indium at first. Indium is, where was it? It's in dark blue. It's underneath the metalloids. So it took me a while to find it. If you've completed it, I have the answers that I got on the board. Let me know if y'all got something different.
Yes.
Oh, it's a 3, sorry, yes. I have a typo, wait. This is where I messed up. See, I thought that was a 4, so my notes show it's a 4. It is not. You were right, that's a 3. Fix that in my notes. So this is like why you want to definitely double check before you do anything. We're only human. Anything else that I got wrong? Okay. All right, so remember that if they have the same charge here and here, you don't have to do any extra math. You know, it's just gonna be as is. So it's just like if it's NaCl. This one we had to not only crisscross it, but we had to simplify it. So it couldn't just be PbO2O4. You have to, you know, divide it by 2 to get PbO2. So you simplified it. Yeah, so you don't forget to crisscross. So this one we crisscrossed and simplified it. Yeah, so check your answers. Make sure you got the same thing as me before I move on. And then I saw this and I was like, it says base. It's actually spelling something. All right, so in part 1, we used fixed charge metals, just the element name. But now in part 2, we're going to start including elements that have varying charges. We have to include them as with the Roman numerals. So just remember, we don't use Roman numerals on the fixed elements. But if it's one of the other elements, you're going to start using Roman numerals for the charge. And then nothing's changed here. So let's practice. Write the formulas and the names for these compounds. Let's do the first one. We have tungsten, which is a W, and it's a +6. Oxygen will always have a -2. So if I crisscross, I now have W2O6, but simplified, it will be WO3. If I need to name it, oh, yeah. Ooh. This would be tungsten, but what charge? It's no longer a 6, is it? Right? We simplified this. What is the charge of this tungsten now? Wait, no, it is. It's still 6. Yeah. I'm like,
Does that ever change?
I think if it was no longer a 6, it would change. But in this case, I just did the math in my head. I'll show you how I did that. If I have -2, -2, and -2, and since I have 3 oxygens, they're each a -2. For this to end up being a 0 charge, I have to have a +6. That's how I did the math in my head. So I just corrected myself and checked myself. Okay, this is still tungsten 6. So it's going to be tungsten 6 oxide. Okay, y'all do the next 2. So what did you get for number 2? So the 4 would go to the oxygen, the 2 would go to the tungsten. So it'd be W2O4. And then simplified WO2. And what will be the name? Yes. Right, and then what about the sodium nitrogen? What's the charge of sodium? And nitrogen? Okay, so I got Na3N. Question, is sodium a fixed number? So am I gonna write sodium 1? No. I'm not gonna put a 1 in parentheses here. So it's sodium nitride. Okay, so I promise you, we're getting to a point where it's gonna be kind of combobulated with everything included, alkanes, maybe not yet, but we'll do alkanes, non-binary, covalent, and ionic. You're gonna have everything in, and we're gonna have to remember those little small rules here. So it is a fixed one. We do not put in parentheses because we always know the charge of sodium will be +1. Okay, now I have the second one we're going to work on. So I'm done with my slides for the rest of the day, which means that we're going to work on this. And then once you are done with this, I highly recommend getting up your homework and we'll start answering the homework questions. That way I'm in the room if you have questions. I'm a great resource for homework problems. So since we have another 25 minutes left of class, we'll do this for about, let's say 10 minutes, and then I can go over some answers, and then I'll probably ask you to start your homework. But if you would like to go, you're welcome to go at any time. But I highly recommend doing these worksheets because if you notice, some of the exam questions came from the worksheets. And if you're online, I will put the worksheet here, but it's also available to you in modules with the answers. There it goes. You too.